So I've had a few videos in which I've had flat earthers try to debunk it using crepuscular rays, saying that it proves a local sun. Well, that's false. That's completely wrong. Crepuscular rays are actually caused by the sun's rays, light, bouncing off of things like water molecules and the atmosphere and different gases and stuff up in the upper atmosphere. And then coming through the clouds, actually reflecting off the clouds a bit, especially if they're clouds that are built up a bit, and is deflecting the sun's rays. Now, I know probably most flat earthers won't believe me, so let's just look at a few videos that actually may explain this in more depth.
Air. Crepuscular rays happen when sunlight passes through air that has a bunch of stuff in it. Sunlight is always bouncing off of stuff in the air. The way it bounces depends on what it's hitting. Nitrogen in the air, for example, scatters the bluer parts of the sun's light, which is why the sky is blue. Crepuscular rays happen when the sunlight hits bigger particles, like dust and water, which bounce all the light's colors pretty equally. And when we see all the colors of light at once, we call that white light, which is why a lot of crepuscular rays look white. Sometimes the rays don't look white, which just means that the light hitting them wasn't white to begin with. So crepuscular rays around sunset will be redder, since sunlight looks pretty red by that point. But crepuscular rays aren't always visible whenever there's a lot of dust or moisture in the air. There also needs to be something blocking some of the sunlight. Without anything in the way, we wouldn't be able to see the paths of the individual rays no matter how much stuff was in the air. Light would be bouncing off of everywhere equally, and everything would look equally lit up. These two things, particles in the air and something to block parts of the sunlight, are why clouds are so common in those Facebook pictures. Clouds are denser pockets of water vapor and dust that are really good at blocking sunlight, and the area around clouds also tends to have some dust and water, so if some light does manage to break through a hole in the clouds, it hits a whole bunch of material that scatters it. But you don't need clouds. Mountains and buildings can also create crepuscular rays, and if the sun is at the horizon, like at dawn or dusk, you can get crepuscular rays that stretch all the way across the sky. So intense. Like all crepuscular rays, they look like they're radiating out from the sun, like a bunch of lines coming from a single point. But the ones right above you will look parallel, and the rays going behind you, directly opposite where the sun is, all meet again where they are called anti-crepuscular rays. And they look like they're radiating out from some invisible sun on the darker side of the horizon. So what's actually happening here? Are the rays parallel, or do they spread out from the sun? Well, both. The sun is so far away that when its light gets to Earth, it's all pretty much going in the same direction. So all of the sunlight causing crepuscular rays is virtually parallel, which means that the rays themselves are always parallel lines. They just look like they're meeting at the sun because of perspective, which makes things look smaller when they're farther away. Just like how train tracks look parallel when you're standing next to them, but they look like they're getting closer together the farther away they are from you. So those beginnings of crepuscular rays far away from you are like those distant train tracks that seem like there's hardly any space between them. Then the rays directly above you are like the train tracks by your feet, so they look parallel. But the anti-crepuscular rays are also really far away from you. They're just as far away as the original ones, so they look like they're coming together just like the original crepuscular rays did. If you could see crepuscular rays from space, you would see them for the parallel lines that they really are. And this is a thing that we know, because astronauts have seen crepuscular rays from space, and this is what they see. So the next time someone puts up some photos of supposedly inspirational crepuscular rays, don't forget to congratulate them on their excellent picture of dusty light. Thanks for watching this episode of SciShow, which was...
Crepuscular rays are always a beautiful sight to see. Sometimes they streak across the top of the clouds, and sometimes they shine down almost straight down to the ground from the clouds. Why do they look so different in different situations? And what makes them visible in the first place? The reason why you can see crepuscular rays is due to scattering. This is a process by where particles in the air, and the air itself, reflect small amounts of light in all directions. This leaves a trail of scattered light which can be seen. If the air were perfectly transparent, you would not be able to see any streaks. Crepuscular rays appear to diverge. This is simply due to perspective. The basic principle of perspective is that if something is closer to you, it appears larger, and if something is farther away, it appears smaller. Specifically, the apparent size of something is inversely proportional to the distance from you. All this means is that if something's twice as far away, it looks half the size. If something's 5 times closer, it looks 5 times larger. So what happens with these rays? As the rays go down to the ground, they also go closer to you. This is because if the sun is in front of you, the rays are going down to the ground at an angle. The part of the ray which is closer to the ground is closer to you, and the part of the ray which is coming out of the cloud is farther from you. This means that the part of the ray that is farther from you will appear smaller, and the part of the ray that is closer to you will appear larger. Take a look at this tape I've put on the ceiling. The tape is equally spaced all the way down the ceiling. But if I go to one end of the room and look across the tape, the lines appear to diverge. This is because the tape that's closer to me looks bigger than the tape that's farther away. Also, the space between the tape looks bigger when you're closer and looks smaller when you're farther away. Again, this is the basic principle of perspective. Things that are farther away look smaller, and things that are closer to you look larger. So this is why crepuscular rays always appear to diverge. However, they don't always diverge in the same way. If you're very far away from a crepuscular ray, the part of the ray coming from the cloud and the part of the ray that hits the ground are both far away from you. The part of the ray that hits the ground is only somewhat closer, so it doesn't appear to diverge very much. However, if you're closer to the rays, the part of the ray coming from the cloud is somewhat far away, and the part of the ray coming down to the ground, or even moving across the clouds if it doesn't actually hit the ground, as in with a sunrise or sunset, this part of the ray is much closer to you, which means it appears to diverge much more. The only time you would see crepuscular rays that go straight down to the ground would be if the sun is directly overhead. And this only happens at certain times of the year at midday in the tropics.
Alright, so here's a video here. It's going to actually show the crepuscular rays moving, because as those particles and as those water molecules and stuff that they're all bouncing off of move along with the wind and air currents, the crepuscular rays will move along as well, because the reflections are moving, the stuff that's reflecting and diverting the light of the sun. Let's check that out. So as you can see, crepuscular rays do not prove a local sun in no way or shape or form. It's simply just water molecules, the atmosphere, the clouds, stuff kind of up in the atmosphere, floating around on different molecules that are simply just reflecting the sun's rays and diverting them to make them look like they reflect out. That's why usually you see crepuscular rays. The sun is hidden by clouds or by mountains, because it's the only time you'll actually see those rays. If you didn't have that, then the rays are spread out a lot more. It's still reflected, but spread out evenly, and so you don't see this crepuscular rays. You have to have the sun's main light source has to be kind of covered up by the clouds or mountains or something like that, or even the curvature of the earth when you have sunset or when sunrise, and you can see those the reflecting coming out. That's how that works. So yes, crepuscular rays do not prove a local sun. The sun is not local. It is 93 million miles away. If you don't believe me, I've actually put up a video which proves this, uses the exact math and tells you the exact process used to confirm the distance of the sun. This was confirmed hundreds of years ago, and they've actually confirmed even further by using radio waves and modern technology. So thanks for watching. Click on the like button, subscribe to my channel, and watch some more videos. Thanks, bye.